Okay, so let's get started. We'll start off with an easier function to evaluate. What is the cosine of 5 pi over 6 equal to? For this problem, we just need our unit circle. Remember that cosine is the x value, while sine is the y value on the unit circle. So this means that we just have to find 5 pi over 6 on the unit circle and find the x value, which turns out to be negative radical 3 over 2. And that's our answer. Simple, right? So let's try a problem with a bit of a twist to it. What is the sine of negative 7 pi over 4 equal to? Well, we could try to use our unit circle, but there's a negative. What does that mean? Well, the negative simply means that instead of traveling clockwise on the circle, we go counterclockwise. So instead of traveling 7 pi over 4ths clockwise, we go the other way, all the way to pi over 4. And remember, sine is the y value of pi over 4 here, so that means that this entire thing evaluates to radical 2 over 2, and that is our answer. Okay, let's try to evaluate another trig function. What is the tangent of 3 pi over 2 equal to? Well, we could use our unit circle, but tangent isn't on there. But remember that tangent is the same thing as sine over cosine, or y over x. This means that to find tangent of 3 pi over 2, you only need to find sine of 3 pi over 2 divided by cosine of 3 pi over 2. So let's find 3 pi over 2 on the unit circle, find sine, which is negative 1, and divide it by cosine, which is 0. But what does that evaluate to? Well, remember we can't divide by 0, so this entire thing actually turns out to be undefined. And that is our answer. Now that we've got the basics down, we can move on to some trickier problems, like this one. What is the secant of 15 pi over 4 equal to? Well, we know that secant is 1 over cosine, or 1 over the x value, so secant of 15 pi over 4 is 1 over cosine of 15 pi over 4. But cosine of 15 pi over 4 is not on the unit circle. What do we do now? Well, we have to make the observation that going 2 pi around the circle gets us right back where we started. This means that if we add or subtract multiples of 2 pi, we're not actually changing the angle. So this means that we can subtract 2 pi from the secant of 15 pi over 4, and this gives us the secant of 7 pi over 4, and the angle is actually the same, but now 7 pi over 4 is on the unit circle, so that means we can evaluate. We find 7 pi over 4, and we find the cosine value, which is radical 2 over 2. We evaluate, and this turns out to be radical 2, and that is our answer. Now let's put everything that we've learned together to solve this problem, the cosecant of negative 11 pi over 3. Now this problem looks scary at first. There's a negative and it's not on the unit circle, but we can solve it with the strategies that we learned. First, cosecant is 1 over sine, or 1 over the y value. Then we use that trick from before where we add or subtract multiples of 2 pi to get to a value on our unit circle. In this case, we add 2 pi 2 times to get cosecant of pi over 3, which is equal to 1 over sine of pi over 3. Now we find pi over 3 on the unit circle, and we find the sine value, and now it's a simple matter of evaluating. And everything, when it's said and done, simplifies down to 2 rad 3 over 3, and that is our answer. Now let's use our strategies one final time to evaluate the final trig function, cotangent. Here we have cotangent of 17 pi over 6. Remember, cotangent is 1 over tangent, or sine over cosine, so it flips to become cosine over sine. Now we use that trick of adding or subtracting multiples of 2 pi to get to a value on our unit circle. So now we just use our unit circle, find the values that we need, plug it in, evaluate, and we get negative radical 3. And that is our answer. Thank you for watching.